Okay, so you're studying higher graphic communication,
Uh-huh.
which can only mean one thing.
Exams.
Yeah, the SQA exams.
Right.
I get it.
Yeah.
Sometimes looking at technical drawings feels like
Oh,
you're
yeah.
trying to crack some sort of secret code.
Absolutely.
But hey,
Yeah.
we've all been there, right?
We have.
We've gone through past papers,
Yep.
examiner reports,
Hmm.
even those YouTube tutorials everyone's talking about
Oh, God,
to
yeah.
try to help prepare you.
Yeah. But remember, technical drawing is all about communication.
Okay.
It's like learning a new language,
Okay.
one that uses lines and shapes and symbols instead of words,
Right.
you know?
Yeah.
So,
And just like with any language, the
Ah.
key is to understand the grammar,
Yeah.
the rules that make it all work.
absolutely.
And that's what we're here to do,
Okay.
to help you decode those rules
Yeah,
and master the language of technical drawing.
exactly. We're going to break down the different types of views
Okay.
used in technical drawings,
Right.
starting with orthographic views.
Okay, so orthographic views,
Yeah,
these are basically the bread and butter of technical drawing, right?
absolutely. They're like the foundation of your house.
Right.
You can't build anything without a solid foundation.
Okay.
Imagine you're looking at an object from different angles,
Okay.
front, top, and side.
All right.
Orthographic views are like taking snapshots of
Yeah.
the object from each of those angles
Right.
and then flattening them onto paper.
So it's almost like those old school photo booths where you get four
Yeah.
different poses on one strip.
Yeah, kind of like that,
Yeah.
but with a bit more precision.
Right.
And the key thing to remember here
Mhm.
is that we're using something called third angle projection.
Third angle projection.
Yeah.
Sounds a bit technical.
It is. It's a standard
Yeah.
way of arranging those views on the page.
Right.
It's how we tell everyone, engineers, architects, designers,
Yeah.
exactly where each view should be placed.
Okay.
Think of it this way.
Right.
You've got an imaginary box,
Good.
and your object is inside.
Yeah.
Then imagine projecting the views of the object onto the walls of that box.
Right.
That's what we do in third angle projection.
Okay.
We unfold that box and lay it flat.
Okay, that makes sense.
Yeah,
So the position of each view is really important.
absolutely. If you mix up those views,
Yeah.
it's like writing a sentence with the words in the wrong order.
Right.
It's still technically English,
Yeah,
but it doesn't make much sense.
I see.
Right.
And those SQA examiners, they're pretty strict about that, right?
Oh, yeah, they've seen it all.
Like what?
Students getting the front view mixed up with the side view,
Oh, yeah?
putting the top view in the wrong place.
Right.
It happens more often than you'd think.
So word to the wise,
Yeah.
triple check those view positions before you even think about drawing anything else.
Yeah.
But let's say we've got our orthographic views all sorted.
Right.
What's next on this drawing adventure?
Well, sometimes you need to see what's going on inside that object.
Right.
That's where sectional views come into play.
Sectional views,
Yeah.
like slicing open our object to see its hidden depths.
Exactly. Imagine taking a giant imaginary saw
Huh?
called a cutting plane
Right.
and slicing through your object.
Yeah.
Then you draw what you see on that cut surface.
Okay.
It's like giving you X-ray vision for your designs.
Cool. So we're basically cutting our object in half and drawing what we see on the inside.
It can be that simple,
Yeah? Okay.
but we can also get a bit fancier.
Right.
We have half sections
Okay.
where you cut away only a quarter of the object
Uh-huh.
to show both the internal and external features.
Okay, so a half section is like having your cake and eating it too.
Yeah.
You can see the inside, outside at the same time.
Precisely.
And then there are stepped sections.
Yes.
which come in handy when your object has different levels or thicknesses.
Yeah, it's like taking multiple slices at different heights
Okay.
to reveal the internal structure step by step.
So step sections are for those objects that are a bit more multi-level,
Yeah,
like a fancy birthday cake with layers of different flavors.
a perfect analogy.
Okay.
And we can't forget about revolved sections.
All right. Revolved sections.
Imagine taking a slice like a wedge of cheese
Okay.
and then rotating it around an axis.
Okay.
Show its profile in a more compact way.
So revolved sections are like those spinning dancers who suddenly freeze in a dramatic pose.
Exactly.
Mm-hmm.
You capture the essence of their movement in a single image.
And finally, we have removed sections.
Yes.
This is where you take a section from one part of the drawing
Yeah.
and move it to another area for clarity.
Yeah, it's like zooming in on a particular detail without cluttering up the main drawing.
So it's like those pop-out diagrams in textbooks that show you the inner workings of a machine without making the main diagram too complicated. Each type of section view has its own purpose.
Right.
And choosing the right one depends on what you want to communicate about your design.
Right. So we've got our orthographic views to show the outside and our sectional views to reveal the inside.
Yeah.
But there's still so much more to explore in the world of technical drawing. right?
Well, sometimes you need to zoom in on specific features.
Okay.
Like that intricate carving on a statue or the teeth on a gear.
Yeah.
That's where detailed views come in.
So it's like using a magnifying glass to get a closer look at something,
Exactly.
right?
Imagine you're designing a new phone.
Okay.
You might need a detailed view to show all the tiny components around the camera lens or the buttons on the side.
Right, because if you tried to cram all those detailed into the main views, it would just be a big mess.
Exactly.
Yeah.
Detailed views let you show those important features with more clarity and precision without cluttering up the overall drawing.
So it's all about focusing on the specifics.
Yeah.
Makes sense.
Uh-huh.
But what about those times when you have a surface that's at an odd angle?
Right.
How do you show that accurately?
You're talking about auxiliary view.
Auxiliary views.
This is where things get a bit more challenging, but also a lot more interesting.
Okay.
Auxiliary views are all about revealing the true shape of surfaces that aren't parallel to the main orthographic views.
Okay, I think I get it. So if you were drawing a building with a slanted roof, you'd use an auxiliary view to show that roof's true shape right.
That's a great example. Cool.
And this is where your visualization skills really come into play.
Yeah.
You need to imagine how that 3D object is projected onto a 2D plane,
Yeah.
but from a different perspective.
Sounds a bit like those mind-bending optical illusions.
It can feel like that sometimes,
Right.
but there are some techniques
Okay.
that can help you visualize and construct auxiliary views more easily.
All right.
So it's all about using those construction lines as guides to create the auxiliary view step by step.
Uh-huh.
But those SQA examiners, they love to throw in those tricky explain questions, don't they?
Oh, yeah. Those can be challenging.
Right.
But they're also a great way to show that you really understand what's going on in the drawing.
So how do we tackle those questions without just waffling and hoping for the best?
Well, first off, make sure you understand what each view is telling you.
Okay.
Don't just blindly memorize drawing techniques.
Yeah.
Really think about what each line and shape represents.
So it's more about understanding the why behind the how.
Exactly.
Right.
And when you're answering those explain questions,
Uh-huh.
be clear and concise.
Okay.
Use cause and effect reasoning.
Cool.
Explain why you chose a particular view or technique
Yeah.
and what information it reveals about the object.
Okay, that makes sense.
Yeah.
So we've learned how to zoom in on details
Uh-huh.
and how to show those wonky surfaces.
Right.
But there's something else I've been wondering about.
Okay.
Something that looks really tricky.
Yeah.
Tangency.
Yeah.
It sounds a bit like a high-level maths concept.
It does involve a bit of geometry,
Right.
but it's more about understanding how shapes connect smoothly.
Okay.
Imagine you're designing a toy car.
Ooh, I loved toy cars as a kid.
You've got those sleek curves flowing into straight lines, right?
Yeah.
No sudden bumps or jagged edges.
Uh-huh.
That seamless transition, that's tangency in action.
So if I messed up the tangency, my toy car would look more like something Frankenstein put together. And it wouldn't just look off, it probably wouldn't roll very well either.
Right.
Imagine those wheels hitting a bump where the curve meets the straight part of the chassis.
Oh, yeah.
Ouch.
Okay. I'm starting to see how this isn't just some abstract concept.
Right.
It's about making things work the way they're supposed to.
Uh-huh.
But how do I actually draw those smooth connections?
Right.
It sounds a bit tricky.
Well, there are techniques, and they depend on the shapes you're working with.
Okay.
Let's say you're drawing a curve that needs to be tangent to a straight line.
Right.
You have to make sure the curve's radius is perpendicular to that line at the point where they touch.
Right.
Think about drawing a perfect circle that just grazes the line without crossing over.
Right. So it's like the circle is gently kissing the line.
That's a good way to put it.
All right.
And the same principles apply to curves meeting other curves.
Uh-huh.
They need to flow into each other seamlessly,
Yeah.
like the waves on a calm loch.
Okay. That makes sense.
So it's all about making sure those curves connect smoothly,
Huh?
no matter what shape they're meeting.
Right.
But how do I show tangency in my drawing?
Right?
Are there any special symbols?
Not really, but the way you construct your lines speaks volumes.
Oh,
Remember those construction lines we talked about?
Yeah.
They're crucial here.
Right.
You use them to pinpoint the exact points of tangency,
Oh.
making sure those curves flow into them perfectly.
So it's like those dotted lines are secretly guiding our curves, making sure they behave themselves.
Exactly.
Oh.
And here's a tip from those SQA examiner reports.
Right.
Don't rely solely on your computer software.
Okay.
Sure, CAD can help,
Yeah.
but understanding the principles of tangency is vital.
Right.
You need to be able to check your drawings, make adjustments, and know that those curves are truly tangents.
So it's like having a sat nav,
Yeah.
but still knowing how to read a map,
Right.
just in case the tech fails, right?
Absolutely. Tangency is all about precision and understanding the geometry behind those smooth transitions.
Yeah. Right. So we've covered a lot of ground here.
We have.
From those basic orthographic views to the intricacies of auxiliary views and the art of tangency.
Yeah, it's been a good one.
I have to admit, I'm feeling a lot more confident about facing those SQA exams now.
That's fantastic to hear.
Thanks.
Remember, this is just the beginning of your journey in graphic communication.
Yeah.
Keep sketching, keep experimenting, and don't be afraid to make mistakes.
Right.
The more you practice, the more you'll develop that intuitive understanding of how shapes and views work together. Who knows, maybe one day you'll be designing the next iconic Scottish landmark.
Or the ultimate iron brew bottle.
There you go.
Either way, I'm ready to put these skills to the test.
Good stuff.
To all you fellow higher graphic communication students out there,
Yep.
keep your pencils sharp and your minds open. We've got this.
Absolutely.